And so I'd like to invite our first presenter, Dr. Thomas Tapen, CEO of EchoICs, to the stage. Please, Thomas.
All right, thank you, Martin. And thank you, everyone, for coming to hear about what we're doing at EchoICs for the efficiency and resilience of cellular networks. So I'll jump right in. Uh, oh, and I should say I'm co-founder and CEO of EchoICs. So EchoIC's mission is to solve the problem of crowded, fractured spectrum in wireless communication with low power and low cost hardware. Now, I don't necessarily expect anyone to even know that there's a problem of crowded fractured spectrum in wireless communication, but you've experienced it if your phone has ever said it's connected to, 5G or 4G or whatever the case may be. But when you try to use the internet, you're not actually able to connect. What's going on there behind the scenes is that the spectrum your phone is allowed to use is just already full from other users. If you're at a sports game or something that's very crowded where this is happening, maybe it's an inconvenience. You can't look up the stats of a player that you were interested in. But it becomes much more important in the case of first responders or in an emergency situation, and especially for military communication networks, it can mean life or death. Right now, also, this is something that might happen only occasionally in a crowded environment. But the need for wireless data is projected to grow exponentially, and those projections have only gone up even further with the adoption of AI. So while right now this is a problem that is most acutely felt on the government military side, it's one that is a focus of the industry as we think about the future of wireless networks. Now, the simple solution, if I said, oh, well, the spectrum's full, the simplest way to serve more users and more data is to just add more spectrum. The problem is we don't really have more spectrum. So this chart comes from the FCC, and it shows essentially all the frequencies that we can reasonably economically use for our wireless networks. You don't need to read any of the small text. The point here is there's no big empty box labeled free space. We've already used all of these frequencies. And so we can't simply add more. We need to get smarter about how we use our networks. So this slide summarizes how networks currently operate and how they're proposed to improve and where EchoICs fits into all this. So on the left-hand side here, hardware-defined radio, that's the way your phone currently works. If all of the wireless spectrum is represented by this rainbow here, all the different frequencies, then your phone is allowed to use a small piece, and if that's full, that's it. It doesn't work. One of the things that's been proposed for the future of wireless networks is software-defined networking, where a radio would capture the whole spectrum here and then digitally process that down to a specific piece. And the benefit here is you can use whatever piece you're allowed to by regulators and that's free, that actually has data capacity left. The problem is the way that this is done currently is very power inefficient and very costly, which has limited its adoption. So where EchoICs finally comes into all this is our technology, which we call flexible spectrum radio, is a third approach, which has all of the flexibility benefits of software-defined radio, but doesn't increase the power consumption and cost. So the way that that works is we still capture a small slice of data and only process what's needed. So that's the source of the efficiency, but it's from a window that we can move over a wide range of frequencies. So again, getting the best of both worlds there. So a little bit about EchoICs, the company, where we are and where we're going. In the later part of 2024, we received a grant from the National Science Foundation and our first customer contract with the defense contractor GERD Systems. That allowed us in the middle of last year to demonstrate our first prototype of this flexible spectrum radio hardware. And we were able to show more than 10 times improvement over what's currently available on the market in terms of those key metrics of uh, interference resilience and power efficiency. And finally, our first minimum viable product is currently being manufactured, um, and we believe will be available to customers in May of this year. So GERD kind of has first dibs on some of the samples, but we'll be able to market that to a wide range of customers in the defense and consumer wireless markets. And the goal is to be able to build up to volume production by the end of the year. And you can imagine that's going to cost us some money, and that's maybe why we're talking here today. So about the market opportunity. I've split up here three different markets, and they're ordered in order of kind of most obtainable but smallest down to the largest, but ones that would require a larger ramp up. So the first market we have here is really that military market. That's where the need is most dire and where the customers are most motivated to try something new. So that's where they have the best customer traction and we feel is the best beachhead market. However, some of those same uh, products that get used in military hardware today are used in cellular infrastructure. So over time, we'd be able to move with the same product line and the same technology into those much higher volume and higher opportunity consumer markets. And this slide shows kind of a rough timeline and an outline of how the revenue would work of ramping into those different markets. So software-defined radio and defense kind of being the first beachhead, again, targeting kind of ramping up starting at the end of the year, and then being able to move into consumer markets after the fact. So the current market landscape actually for these parts is very simple. There's an effective monopoly by a company called Analog Devices, which is well known in the wireless hardware industry. They sell the same kind of core product lines to both those defense software-defined radio customers and actually to the current 5G infrastructure players, the big three of those being Nokia, Ericsson, and Samsung. Um, EchoICs, as we said before, has developed flexible spectrum radio, which is able to be just as flexible as these products that are currently being sold, but much more efficient and resilient. So we believe this is the kind of market space that we'd be able to disrupt as a competitor to analog devices. Our team is summarized on this slide. So I'm all the way on the left, and along with Alala Kanafuye, we form the core design team today, and we've been full time with EchoICs for since those 2024 grants and customer revenue. Elisa Apsel was our PhD advisor at Cornell, where the technology was invented. Um, guess I should mention I'm the co-inventor of the technology, in addition to currently the CEO. And then in addition to that core kind of academic and technical team coming out of Cornell, we have two industry advisors, both with over 30 years of experience at companies like Google, Qualcomm, Intel, and AMD, who have taken complex silicon products to market. So they really have the experience in really doing this kind of work in industry. Now, EchoIC's business model, if you're familiar with the industry, then we're a lean fabless semiconductor company. Now, for those of you who may not be familiar, what that means is that if EchoICs is here, we want to deliver hardware, that is chips, to our customers. And the way that we do that is that we don't build a whole fab and manufacture them ourselves, but we work with a third party and a foundry where we provide them the design and specifications, and they do the manufacturing and send us packaged chips. So just to be clear, what EchoIC's role in this process needs to be is we need to um, produce those designs. We need to manage those customer relationships in our inventory, but we don't need to have a whole foundry or invent a new manufacturing process for any of the technology that I'm talking about, which helps with the headcount and scalability of what we're proposing. This slide shows a breakdown, and it's a little busy. We can get into it maybe more in the Q&A, but over the next few years, a breakdown of customers, revenue, and the expenses associated with that. And the kind of key thing is that establishing a volume production line with those foundries, TSMC being the one I highlighted on the previous slide, um, requires upfront money. And so that's where the need for some seed funding comes in and the gap comes in this year. So finally, our ask, what do we need to actually achieve this? Well, the projections you just saw assume that we get a follow-on grant from the NSF, which in the past has been likely. Right now, it's a little more up in the air. But for the purposes of this presentation, assuming that that comes through, then we're looking for an additional total 2 million in seed funding. And I should also note that over the long term, uh, uh, we're looking for potentially a CEO so that I'm not kind of trying to juggle both CEO and essentially CTO duties. So with that, thank you, and open for questions.
Thanks, Thomas. Um, do we have any questions, comments? I don't see anything in the chat. Does anyone want to?
Maybe, maybe Thomas, can you comment on
Mhm.
the dual use possibility of your technology because you were funded by some defense related, and your products is that different for the different use, or you mentioned something about doing production this year, how that's related to the different markets.
Yeah, so let me talk about two slides here. I guess this is a different version of the slide that you saw.
Mhm,
You don't need to worry about all the text here, but the key is for that kind of first minimum viable product that we're talking about here.
mhm,
That product is already in the one that's currently available in the marketplace is already dual use. So it's the same range of products that
mhm,
go to both those defense applications and into cellular infrastructure.
mhm,
The other piece that I want to emphasize that was
mhm,
just hard to fit into the pitch is that
mhm,
flexible spectrum radio is really a platform technology. And so
mhm,
I've been very focused on the minimum viable product, but
mhm,
there's actually a range of products that you could develop with that technology over time. And this shows a couple of different
mhm,
of those different applications.
mhm.
And so once you get into that, maybe some of them will be more defense focused and some will be more consumer focused. But right now, our first product is designed to be very much dual use, and it fits into the existing market of dual use parts.
I see. All right, thank you. Mm.
Thanks, Thomas. Thanks, Alice. I don't see any other questions. And I think
Hey,
we're just
Martin.
about on time. Yes,
Hey,
please.
it's Dan Stoller. Thomas,
Okay.
great job. Thanks for the pitch. Question for you. Do you envision as you enter sort of the later markets in for the telcos and the 5G, 6G, are we talking about this is on the tower side of the ecosystem in the phone itself? Like where does this, look out to the future? Where does this live in that ecosystem?
hmm So we think that the first place it would live is in the tower, and that's because that's where these products that Analog Devices makes are already used. It's a component that goes inside what's called the radio unit, which are those boxes that go up on the towers.
Yep.
Um, However, as I was highlighting on this slide, the technology is really a platform. So once we have some traction in that market, we think it's very highly applicable to what's called user equipment, which is cell phones, and that
Got it.
dramatically increases the volume and the market opportunity as well.
Yes. Thank you.
All right, thank you. I see Sunil, but I think that's going to have to be the last question. We're already a little bit over. Apologize.
I'll
Um,
keep it really short. Thank you.
sure.
Thanks again for the presentation. I guess the quick question I have is, you mentioned 5G/6G, and obviously given where the trajectory is of the market, um, do you think that focusing on 6G alone at this point, is sort of the way to go here? Part of the challenge that I have is I think it's difficult to have any real conversations around a 5G market. But I'm wondering if there's a particular reason why you're doing or you're positioning it as just given where we are with 5G.
Yeah, so there is a specific reason there, and it comes down to that infrastructure cell tower market. One of the problems that 5G has faced for network operators, so the people who actually pay for all that stuff, is the operating costs, and a lot of that is power consumption. So improving the efficiency of current networks is a market opportunity for this technology. But you're right, the larger opportunity would be in 6G where things are going to change and different technologies are going to be adopted to a greater extent. But that's one piece where it could fit into the current markets without assuming any changes or any specifics about what 6G looks like.
Okay, thank you. I'll reach out to you offline and we'll take it from there. Thank you.
Yeah,
Great,
please
thanks.
do. That's great. Thank you very much. Thanks, Thomas, for a great presentation.